Exchanges work, forex exchanges, stock exchanges, and kind of basing that all on the exchange that I built, which is called Bitfloor, and it's a Bitcoin exchange. And obviously, we're talking about money, and this is a very serious presentation. That's why I'm dressed up. There's going to be a lot of business talk in this presentation.
Synergy!
Absolutely. Right there, we have synergy. Right there, as you can see, everyone can see we're all holding hands. So, okay. So, the agenda, because all business presentations have to have an agenda. I'm going to talk about the exchange architecture, kind of like how a stock exchange or a forex exchange marketplace works, what are the big terms you should be aware of, why I kind of wrote it in Node.js, how I did that, modules of interest, things that made that work. Obviously, math was important, some other little things here and there. And then there'll be synergy, as someone already pointed out, and then profit. The disclaimer, obviously, I have to put in the opinions expressed in this presentation are mine, not my employer's. I am my employer, so you'll have to take from that what you will. So, as Lou said, I have a background before starting the exchange. I worked at a high-frequency and automated trading firm. That's where I kind of learned a lot of the concepts that I then took and applied to making the exchange. I've been using Node.js since kind of the 0.2, 0.3 days, played around with it for some web apps, so I didn't one day decide, well, I'm going to build a new exchange and I'm going to do it in Node.js, which I've never used before. No. I kind of knew what I was getting into a little bit, but, it's been fun and it's been nice and it's worked. Why make a new exchange? Well, there were already a few Bitcoin exchanges at the time, but myself and the co-founder that helped me start the exchange, we didn't really like what they were offering. Some of them were really unusable, like beyond unusable. We're actually amazed that people were able to successfully place orders on them. And just, they didn't seem very professional. So we wanted to change all that and kind of bring people that had worked on financial products in the fintech space and make an exchange that seemed more reasonable. So, the company and the exchange is called Bitfloor. That's the corporate seal. Because whenever you register a corporation, you need to provide a corporate seal. So, that's the corporate seal. It's been around since August 2011, which is not that long. Bitcoins themselves, if you know about what Bitcoins are, on the last page, they can talk. Internet Nerd Tokens is probably the best and most accurate description today. It's an online digital currency, in simplest terms. And so at peak in July and August, I was moving about $700,000 US in trading volume through the exchange. That's a 30-day window. It's gone down from that for various reasons, because dealing with US dollars is like an up and down process, as your banks close accounts and things like that. I've seen various forms of deposit over the lifetime of the exchange. I've taken cash deposits, Walla, other electronic payments, many of which have been shut down because of various issues, which I'll talk about in person, but this is not a talk about that. And Bitcoins themselves are a very early stage type of thing. There's a very small user group, of people that use them on a daily basis and try and push it forward. It's still very much in its infancy. Companies like PayPal have been around since like 1998. So you can imagine something that just started a few years ago is not going to have the same widespread adoption. It takes time to change things, as we know. So, I said I was going to talk about how markets work, and we're going to start here. Most of you have seen something that looks like this. It's a tick chart, a stock chart, Google Finance. Maybe it's the thing that tells your portfolio is doing well or not so well. This one seems to be all right. Who knows? But where does this type of data come from? It's not magic. It's not that you just log into Google, or Yahoo Finance or Bloomberg or whatever, and the data's just there. It comes from somewhere, and there's a whole exchange that creates this data, and that's what I'm going to talk about, how that data is generated, how do we make this chart. So, it starts with an order, and an order goes to what's called a matching engine. the matching engine contains the order book. Okay, that's basically at a fundamental level, that's what is happening. You have orders, which are people like yourselves, that say, I want to buy or sell some particular stock, currency, it doesn't matter, and you send that order to an exchange, like Bitfloor, like NYSE, like, BATS, like any of the NASDAQ ones you might be familiar with, and they'll, take that order, and depending on the properties of that order, the size, the price, level, whatnot, they'll place it on what's known as the visible order book, okay? And this is an example of how you can visualize maybe an order book. You see that here you maybe have prices, that's $11.80, and you have some amount of volume that someone is willing to sell at $11.80, right? The blues are the asks, which are sellers, and the red are the bids, which are buyers, okay? So you have a bunch of people, you can imagine it's like an eBay auction. You just, instead of one seller and many buyers, you have people on both sides, okay? And most of these matching engines, which take all these orders, work on a first-come, first-served basis, which means that if you're the first one to the market, your order will be honored first when it comes time to, execute at that price. This is why you hear about all these cool stories about all these HFT guys, they, try and outrace all the other people. They want the fastest networking gear, the fastest equipment. They want to be co-located because there's an actual advantage to speaking to the exchange, a millisecond, a microsecond faster, okay? So that's kind of where all of that comes from. The order books, the interesting properties of them is that generally they're sorted by size. So the highest bid, which is $11.60 in this example here, is the inside of the book as far as bids are concerned. So that's the guy that's bidding the highest amount. He's willing to pay the most. And the lowest ask is $11.80. That's the person who's willing to sell for the least. Okay? There can be invisible order books, but we're not going to get into those dark pools, stuff like that. That's for fancy traders, not for us. So, the difference between, does that come on the slideshow? It does, okay. So the difference between the bid and the ask is, what's called the spread. So if you hear these words on the news or whatnot, you talk about people like trading between the spread or you have to cross the spread. All that means is just someone that saw the price of like $11.60 versus $11.80 on the previous slide. Now they're going to say that, well, okay, if I want to buy now, I have to pay $11.80. So I'm going to go ahead and do that, okay? So they're going to send their order to the exchange for $11.80 to buy, and they're going to hit that sell right here, right? The $11.80 sell, and they're going to execute, right? And so now the matching engine gets that order and it executes, and we get a tick. So if you can imagine over here, I have some order flow. This is our magic, order flow over here. We're going to buy 5 shares of something. It doesn't matter. Usually it don't really matter. At 1 magic unit of something else, $1, 1 Bitcoin. Again, it doesn't matter. And then we have another order, sell 2 at 3, buy 2 at 2, buy 2 at 1, sell 3 at 4. And then now you have someone that wants to sell 1 at 2. And since there was already someone that was buying 2 units of whatever magic thing we're selling at 2, the seller wants to sell 1 at 2, will execute with that buyer, and it will tick at 2. The tick will be, if we go back to our chart, it'll be somewhere on this chart whenever it happened, and the price will tick off at 2, right? And this is the price you see when you say, like, Google is trading at, $600 something or whatever the trading, or Apple is trading at that price, then that's what it means. That's the price. That was the last price someone was willing to pay. Okay, so it's not necessarily the spread price when you just look at the order book. It's the last price someone was willing to pay. So you too can influence the ticking of the market just by paying, what the rates are. And the folks at Bloomberg here were very nice to hook me up with, maybe this will show. Yeah, I don't know. Well, you can stop by their booth later, and they'll show you a live order book from the actual market that's running now, right? So you can see this on a lot of different platforms, and you can see all the prices changing all the time. The actual exchanges have tons, hundreds, thousands of orders that come in a second, so the price is always changing. You can see that happen in real time. Maybe at the end I'll show you. Okay, so if you crossed the book, let's say we did sell 1 at 3 or something, and we didn't get sell 1 at 1, and we didn't get executed, now you have a matching engine that's broken. This is not good. If you placed orders and they kind of crossed over into the other zone, and they didn't execute, then you kind of want to talk to your exchange about that. And this is where, again, you have a lot of the HFT people that do a lot of investigations into when their orders execute and executing quickly. So, you might be asking, well, I can't click things. Yes, excellent. What does this have to do with JavaScript or JS? Why is it telling me all of this garbage about trading systems and exchanges? Well, it's so that I can show you a diagram. What presentation would be incomplete without a diagram? So this is basically how BitFloor is architected, and all of these various components that you see here, minus obviously Postgres and MongoDB, are written using Node.js and JavaScript, right? A lot of them are distinct components, and I'll go over why they're written like this. But all of these components are what goes into making that process I just outlined happen, right? So we have the matching engine, which is the kind of brains of the operation. It takes in all these orders, it maintains the order book, and it's the state of the system, okay? And you have all of these other gateways, which maybe you'd be more familiar with. REST, so there's a REST API. If you want to do trading on the exchange, you don't have to go to the website, manually enter your order. You can write a trading program that will trade for this, and you too can do this. The REST API is freely available, public, it's documented. So you can be, your own automated trading platform today if you want it to be. There's a website, obviously, that's where you register. You can do manual trading through that. And there's a fixed API for the finance people in the room, which is maybe 4 or 5 finance people in the room. It's an industry standard type of API for communicating with exchanges. Why? Because I could. And WebSockets for streaming out market data. Okay? And fundamentally, this breaks down into 2 different things, which is order entry. That's how you tell the exchange what you want to happen. That's placing orders, canceling orders, all these fun things. And market data. And that's what the exchange emanates. Okay, that's the data coming out. That's when ticks are happening, when new orders are being received. So when writing this, it was a very good fit for a lot of Node.js and JavaScript principles because it's a very event-based system. Right? There are events happening and you just have to act on the events. The other details of the exchange, there's some back office things like clearing. Clearing just means that, okay, so an order happened, Bob traded with Alice. Well, just because that order happened doesn't actually mean that Bob's money or whatever he was selling went right to Alice, whatever she wanted to buy. That process in normal stock exchanges could take a few days to settle between clearing firms. At BitFloor and a lot of other online Bitcoin exchanges, it happens instantly. They are the clearing firm. So as soon as you place your trade and as soon as it executes, you have the other currency, the other thing you wanted to buy, right? You could think of clearing as potentially like receiving your item from eBay. You pay the person through PayPal a few days later, and then a week later you get your item. And once both parties have what they have, it's cleared. Your auction is done, right? So, some more about the matching engine. It's, like I said, it maintains the state of the entire system. The one we wrote specifically has no database communication. So all of the gateways are responsible for identifying, whether you're a valid user, checking things like your API key, checking that you have the right amount of money available. All that stuff is done by the gateways, right? Which is nice because you can just easily drop more gateways on top of the matching engine, and they can expose connectivity however you want. You don't have to rejigger the matching engine anyway. It works using TCP input and a write-ahead log, so we honor all requests that the matching engine actually gets. And something it does a little different than I don't see a lot of Node apps do, which is multicast output. Multicast is this type of network topology, it's the best way to put it, I guess, where you can just send out UDP packets onto the network to a given IP address and port, and whoever wants to receive those needs to quote-unquote bind or be a member of those IP and port groups, right? So you get a kind of pub sub that's built into the OS layer. Not a lot of people know about that, but you don't have to roll your own kind of pub sub implementation. The operating system is already doing it for you, and pretty well, actually. It just sends out JSON messages. It's very straightforward to parse. You can use streaming parsers, whatever you want. That's nothing fancy. And for testing, obviously the matching engine has to be correct. It would be very sad if, I was buying at $4 and someone was selling at $5 and it matched us. This doesn't really make much sense. Our prices were not, crossing or overlapping or anything like that. So we check things like state and the output. So it's very important that each time a message is received, the state of the matching engine and what it output is what we expect that to be, right? All the numbers, all the prices, all the levels, everything has to match, right? It's money, it's people's actual money. So it would be sad to be wrong. And when you're wrong, people will start abusing that. They figure it out and start making erroneous trades and just kind of siphoning money slowly away from the system. That type of thing is very hard to detect if you're not proactive about it. Order gateways. This is the stuff that would be interesting to you people. Because you can go and write an automated trading bot today, right? There are some Node.js libraries you can use. There are some Python libraries. So you can write automated traders in JavaScript, which is pretty cool when you think about it. You can connect to an exchange and start trading using just JavaScript, and it can work. You can consume all the data, from WebSockets if you want streaming data. You can poll using REST for market data. It's pretty straightforward. And like I said, the system design makes it really easy to add other types of gateways if in the future, some really interesting and compelling technology comes along that people want to connect with. It's not hard to add that, okay? Because it's all kind of modularized, which is nice. Okay. And I already talked about multicast a little, but I wanted to touch up on it a little more in that, you don't have to go searching for a solution to this kind of pub/sub problem. Just look into multicast. Node has built-in support through the dgram module for multicast, so you can kind of get going with that very easily. But you do have to keep in mind that UDP could potentially lose your packets on the network, but in reality, you're not going to lose your packets on the local network. It's going to be a long time before you start losing packets due to UDP. So you can look into that, and I recommend that for those of you who don't know about multicast and UDP stuff. Don't be a hater. Not everything has to be HTTP. There's some other protocols out there. All right. I said I was going to talk about modules. Look how happy these people are. It's fair. Who's ever seen a business meeting with people this happy? This is amazing. We're hopefully going to be this happy when we're talking about modules. We'll see. I'll probably anger some people. So, first thing I want to talk about with modules, before I talk about any of the modules that I thought were interesting, is that I see this mistake happen, and I think it's a mistake, and I've been bitten by it before, and I've seen other people bitten by it, where you publish your NPM modules and you leave a loose binding to the dependency. Use that cool tilde feature, or greater than or equals to some revision number, or #x, You want those bug fixes, those critical bug fixes. You don't want to leave your users out in the dark. Or, God forbid, if you publish something that has just a dependency with star, well, I don't know, you deserve the hell that's coming to you. So, basically, the idea is that you don't need another solution on top of NPM. NPM already does good version tracking. You just have to specify the version you want. And it's important to remember that if you don't pin your versions to the, whatever you call the last one in the symbol, all three of them, no variables, you can be deploying different versions at different times of your app, right? And this is very annoying to debug. If you think you deployed something, your test environment has one version, you deployed on one server, one version, now you deployed on another server, version 0.3 of something because you were wanting those crucial bug and security fixes. And now you're just making it harder for yourself. So I try to tell people that you should just be pinning your packages and your module numbers in your module, package.json file. For those of you who know what the package.json file is, which I hope is everything. And especially if you're publishing modules for other people to consume. You're just being mean to your fellow developers if you just let the package version vary and then you're making them install different and debug your problems, right? Because whenever you have a dependency, it is your problem, whether you like it or not. As soon as the dependency breaks and causes a break in your system, your users don't know that you depended on, module XYZ. They just know that they used your thing and it broke, right? Now you have to go fix it. So, basically, yeah, pin your fucking modules. Okay? I don't want to deal with it again. On to more exciting and happier times. These are two pretty important modules that I wrote as a result of working on the Exchange. The int one, they're both pure JavaScript, and I needed that because I wanted client-side accurate math. Because if any of you know about this, if you open up a node terminal and type 0.2 plus 0.1, you're not going to get 0.3, by the way. It's just, that's not how computers work. And if you're surprised by that, we need to have a talk. We do. So, certainly if you're a bank and you're exposing some web interface to your users and, they go in to buy or sell something and your online calculator tells them 0.2 plus 0.1 is not 0.3, well, I don't know. Maybe I'm not spending storing my money with you anymore. It's questionable. So num is the fixed point decimal library that's built on top of int, and int is the arbitrary precision integer library, right? Sometimes you want to store big numbers, like it says. Numbers are very big, and JavaScript, doesn't have classes built in to store these giant numbers. NOTP, these are all node modules, by the way. It's just kind of cool stuff. NOTP is two-factor auth. It's backed by a free application for iPhones, for Android, for BlackBerry called Google Authenticator. And it's an open protocol about how to do these one-time pads. That's what it stands for. And so it's just something, depending on what type of app you're building, you might want to think about. Maybe your new little media aggregator site that requires everyone to specify their emails and passwords again isn't that critical. But if you're doing with something that some people are relying on more heavily, you might want to consider that. And you'll also want to consider that people apparently just format their phones and forget these passwords and you have to reset them. You can also use Twilio to send people these one-time pads. That's a pretty cool use case if you know about Twilio and their phone API. You can just call someone up and go, hey, your one-time password is blah, 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 and you have to enter that to the web page. It's quite easy to do, and it works. I think there are even some online demos of that. You just install a module and it works. Raven, GetSentry.com. There's, I think, another one that's pretty popular called Airbrake. I just, pimping out this one because I like it. What happens when your ship breaks? And I know that there are many amazing developers in this room that write code that never breaks. And, I'm sorry to say that I don't. I write code that breaks actually all the time. Every little thing, if I change a character, I'll probably break something. It's very painful for me to program these days. So, do you know what's going on in your system when things are breaking? Right? If your servers are going down and things are crashing, and users are getting 500 pages or whatever, and you don't know why this is happening, you need to reevaluate some life decisions. Because, it's important that you be able to fix the problems you're causing. And one way to do that is using some sort of, error reporting application, whether it's homegrown, whether it's one of these. I like this one because it's hosted for you, but it's also an open source product. So if I'm going to base my infrastructure on something that I'm relying on, I certainly want to be able to take that and run it myself if I need to. That's pretty important, Consider what you're depending on, and if they're just going to disappear one day, well, now I got to rewrite everything. Maybe not so nice. And, if you're not going to use this, use Tail, email, Sysla, I don't know. If things are crashing, you should know about it, or else you shouldn't be deploying things to production. And just because you know about it doesn't mean you need to do something about it. You should just at least know about it. Logging. There are also quite a number of interesting logging tools that you can use, and you should be using. Console log, not a big fan. It's great when you're developing, but you lose a lot of information, especially if you have an error reporting, stack tracing, or you want to capture a request that may be bad or trying to break into your system. Console log is just not, it's a good friend, but it's the friend that's not there when you need him to be there. And it's just sad, right? So there are these other ones. I got a book, it's a simple one I wrote, but Winston, Bunyan, Debug. Again, do something. I recommend heavier ones like Winston or Bunyan or Book, mostly because you can log error objects, you can log more complex strings, requests. And then if you ever want to drop in a service like Raven, Airbrake, or Logly, any of these things, you can easily just add that into the stack they provide, and you have all those capabilities, right? Console log, sure, some people will tell me you can override override that because it's JavaScript and whatnot, but good luck. That might not be so nice. So, don't make it harder on yourself to debug things. And that has been really important when running the exchange, because it's just me that runs this thing, right? It's just me. So when things break or there's a problem or whatnot, I have to be able to identify it, fix it, and understand what's going on. There's no, like, if you've ever seen Visa's, command center where they run operations for, the entire world. It's pretty impressive. Yeah, I don't have one. I just have 2 monitors at home. Just kind of sitting there programming. Yeah, one day maybe. And the last module that I really like is called Spaceport. And it's, at first when I was deploying things to the Exchange, I was configuring where services live, what IPs, what kind of machines, basically what ports and whatnot. And that got kind of annoying to make sure that I was updated and whatnot. So when breaking services up and down, you want to look at something like a service registry. They have more uses than just like, a single service environment. You can use service registries with HTTP proxies if you're running like Node HTTP proxy or anything like that. You can, code up your proxy, and when certain services come up, those routes become available. What's nice about the Spaceport is it's based on like ZeroConf, if you know anything about that. There's no central service that's managing this registry. It's, again, using the magic of multicast. There's a theme here, I kind of like multicast. If you work in finance, you're going to love multicast. It holds a special place in your heart. It leverages multicast so that you can just discover other things on the network. And if you want to hop networks, hop subnets, things like that, you can use tunneling. It's quite easy to do. But again, don't reinvent tools that are there. And the kernel provides wonderful things like multicast for us. And to close out the talk, remember, sales numbers are up, projections are looking better than